Can you explain the Duckworth Lewis Stern method? I've been putting this off because I want to do a good job of it because I love the Duckworth Lewis Stern method. Let's try. Firstly, it helps to briefly explain what came beforehand. In the old days, it was just done on run rate. If you got 250 off 50 and then the rain came and it was reduced to 40 overs, they'd say, well, you scored at 5 and over. So the new target is 200 off 40, which is also 5 and over. And that sort of worked, but then it spectacularly didn't. The decider of the tri-series of 1988-89, Australia and the West Indies, here's what happened. Australia began slowly, as was the nature of the day, 2 for 83 after 23.1, then the rain came. And it was reduced to a 38-over game, and Australia went berserk. They got 143 off their remaining 14.5 to finish with a very impressive 4 for 226 off 38. In reply, the West Indies got to 2 for 47 off 6.4 when the rain came again. It was reduced to an 18-over game, and the target became 108 based on run rate, meaning the West Indies now only had to get 61 off 11.2 overs, which they did easily. And the realisation occurred that, it's a lot easier to score runs when you haven't got to do it over so many overs, hence the run rate theory is wrong. So what they should have done at this point was consult the mathematicians. Instead, they consulted cricket experts. Now, I love Richie Benaud, but he got this wrong. He was part of the committee that put together the solution, and they only considered the problem that had occurred beforehand. They didn't consider all eventualities. And the idea was, in situations like this, we will only include the highest scoring overs that the opposition came up with. That way, in a situation like this, if it had been reduced down to as 18 overs, Australia's 18 most productive overs would have been chosen, and it would have been a much higher total. That seemed to work, but then the farcical moment in the 1992 World Cup occurred where South Africa needed 22 off 13, the rain came, they lost 2 overs, and they looked back and saw that England's 2 least productive overs had 0 and 1 scored. So then South Africa needed 21 off 1. I think the scoreboard actually got it wrong, which was obviously farcical. And so finally they said, it is time for the mathematicians. Frank Duckworth and Tony Lewis, seen there, realised that it came down to 2 factors, or resources as they called it. And they were, how many overs did you have left? And crucially, how many wickets did you have left? So they studied hundreds and hundreds of games and discovered that there was an exponential decay that was constant or very predictable based on how many resources you had left. And then they did some very complex maths behind the scenes, which is beyond the scope of this. But what they came up with was, and so they were able to come up with a table that in the early days looked like this, that shows how much resourcing is left. So take that example just above my head there of 81.0. That is after 44, when there are 44 overs left, and if you've only lost 2 wickets, you have 81.0% of your resources still available. This was the first time that this had been taken into account. I mean, if a side in a 50-over game after 15 overs is none for 130 and the rain comes, they're in a very, very, very different position than a side who is 9 for 130 after 15 overs when the rain comes. So let's look at a couple of examples. But beforehand, let me point out that those tables are not for the top-level cricket anymore. They are much more sophisticated now, and you need computer software in order to get the actual numbers. But those tables are still used for lower-level cricket. So if you're going to quibble and say, they don't look perfect, it's actually a lot more sophisticated at the top level. Starting with an easy example, say it's a 50-over game, the side batting first has got their overs in completely, but the rain comes down and the second side is only going to get 40 overs. They will start with 10 wickets in hand, and you see the yellow that I've circled there. 40 overs is deemed to be 89.3% of their resources. So all we have to do is reduce the original total by a factor that takes that into account. So if it was originally 250, that means is you multiply 250 by 0.893, which gives us 223.25, which is rounded up to 224, which is a lot more than the example I gave right at the start, which is as it should be, because the team batting second knows that they're only going to have to face 40 overs and they can allocate their resources. Another example, this one a little bit more complex. Team A has made 273 off their 50 overs. Team B has reached 2 for 70 off 19 when the rain comes. Rain comes only for a little bit of time. When they get back on, it's going to be a 36-over game. So, what do we have to do to the scores? Well, we ask ourselves the question, how many resources has Team B got left? They've got 31 overs left because there'd been 19 overs, and they have lost 2 wickets. So you can see that triangulates, if that's the right word, so they have 68.6% of their resources left. So they have 68.6% of their resources left, which means they have used 31.4% of their resources. And they have 16 overs more that they're going to bat. What percentage of their resources will they use in that time? 17 overs left. So they've got 17 overs left. They've lost 2 wickets. They have 46.7% resources still available to them. So add that to the 31.4%, and you get a total of 78.1% are the total resources that are going to have been available to side B. And so we just multiply that through the original target. 0.781 times the original total of 273 gives us 213.21. Rounds that up. The new target is 214. And just a reminder that those tables are outdated. The modern tables are more sophisticated and take into account other variabilities. We actually don't get them. You've got to get the computer software that's proprietary software of the ICC, I believe. And it works just as well for T20 as for 50 over cricket. They've done it for T20 as well. It's a misnomer that it doesn't work so well for T20. It does. I don't think I've done a very good job of explaining it. Hopefully it sort of starts to make some sense. If you've got any questions or want to find out anything else, please feel free to put them in the comments and I'll see if I can dig my way through them and work out a few.